conference. Ajit is a Senior Director of Systems Engineering at LexisNexis Risk Solutions and has responsibilities for enterprise architecture and database engineering. He has a bachelor's in engineering from IIT Mumbai, India, and a master's in engineering from University of Cincinnati, Ohio. Welcome.
Thank you. Hi, can you hear me? Okay, thanks. So, thanks, Apurva. So I come to you from LexisNexis Risk Solutions, and I'm going to talk about HPCC systems. So HPCC systems is a big data platform. This was developed in-house inside my company. We've been working on it for approximately 15 years, and about 5 years ago, we realized there's a lot of interest in the industry and community for a big data platform, so we open sourced it. So it's Apache 2.0, fully open source platform, comprehensive big data platform, and it's available for free for download online at hpccsystems.com. I'll use this. This is working. It's all right. So before I dive into the details of the HPCC platform and what it can do for data scientists, I want to spend just a couple of minutes talking to you about my company. So how many of you have heard of LexisNexis? Okay, that's good. That's more than I expected. But LexisNexis, most of you might know of it as a company that provides legal information to the legal community. I'm not part of that division of LexisNexis. I belong to the Risk Solutions group, and what we do is provide solutions for assessing the risk associated with doing business with a person or an individual. The easiest way I can explain what we do is by giving you a few examples. The first one I want to talk about is if you ever were to do business with a financial institution, say you want to go and open an account with a bank. The bank or the financial institution is going to ask you for your name, social security number, date of birth, address information. And then they need a way to prove that identity, to verify the identity, establish that you are indeed who you say you are. And they do that by making an API call to a service or a product that my company hosts for them. That's a major component of what we do. And we have penetration across a vast majority of the financial service institutions in the United States. And the second set of solutions that we provide is identifying and locating an individual in the United States. So if you're an adult person living in the United States, we have a comprehensive set of public records which allow us to identify where an individual is, their location, and again we provide web services that credentialed businesses can access and locate an individual or a business in the United States. The third thing that I want to refer to is insurance data solutions. So if you were to go to like Geico.com or StateFarm.com and go get an insurance quote, so most of the times when you're interacting with these portals, these companies are making API calls back to my company, and we give them an assessment of how good driver you are, your driving history, and that data and the scores that we send back is used to give you an insurance quote. So all that information goes into the modeling that the insurance companies do. So we are a comprehensive provider of that information in the US. So what is HPCC? It's a comprehensive big data platform. Like I mentioned, we've been working on it for over 15 years, and these are some of the major components that go into the HPCC. Again, this is not a monolithic platform where you have a bunch of CPUs and a vast SAN associated with those CPUs so that you can process your data. This is truly distributed. So those of you familiar with the Hadoop and the ilk, this is very similar to that. It's based on commercial off-the-shelf hardware, and this is a set of programs that can string together hundreds or thousands of machines together, and then you can use that to do your data science. So here are the major components of the HPCC platform. The first one is we call the Thor. The Thor is very similar to your classical Hadoop infrastructure. So this is the component in which you would ingest your data, you would do your analytics, you would build indexes, you would do your searches, you get the classic MapReduce that you would do on a Hadoop cluster. This is the platform that you would execute your programs on. The other major component of the HPCC platform is the Roxy platform. This is what makes it very different from the classic Hadoop ecosystem. This is a truly distributed search platform. Taking a step back, the Thor platform is more for batch processing, so it's single-threaded. If you wanna, you have big data that you need to analyze. That would be done on the Thor platform. But once you've analyzed the data and you are ready to build your indexes and then run your parallel searches, that would go on the Roxy platform. Now, for the data scientists in the room, this is a truly distributed platform. So the machine learning modules inside the platform are truly parallelized and distributed. So you can use the power of the distributed platform to run your machine language tools. The next component that I refer to here is we call it the ECL language. This is a declarative language that you can very expressive. So you can use this to express your program. So anyone who's familiar with a higher level language can pick up ECL very easily and use that to write your programs. We also have a comprehensive web services platform that kind of ties this all the Roxys and the Thor together. So we really think of this as a complete platform which allows you to do allows you to work with big data in one box. So we've been using this internally to run a large company for several years now. So we like to think of this as a big data platform with batteries included. It really allows you to focus on the data science problem at hand and not with Hadoop and all the myriad components that go into making the ecosystem work. We also have a comprehensive IDE. It used to be a C++ Windows application, but now you can use it as an Eclipse module, so it fits right in with the workflow most programmers have. This IDE is more than just allowing you to write the code. It also allows you to visualize the components of the execution as it executes on the parallel platform. Once you have your data problem reduced to a data graph, you can visualize the nodes in the data graph and also interrogate the data, the nodes, to see what kind of processing is going to happen inside each of the nodes. So you can see the records that are being processed, the skew, and how your algorithm is being executed by the platform. The last thing I want to talk about is the ECL. I referred to it already. It is a declarative language. It's really very expressive. You can do it. The parallelization is implicit in the platform, so you don't have to worry about parallelizing your algorithms. So as long as and allows you to completely focus on the data science problem at hand. Again, this is something that we are using inside our company. It's a $1.7 billion company in terms of revenue. So there's a significant amount of business that we are doing on this platform. So it's robust, comprehensive, and it's been in production use for a long time. This is an example demonstrating the 6 degrees of Kevin Bacon I'm not going to bore you with it, but we have these examples and the ECL code associated with these examples on hpccsystems.com. I encourage you to go to the platform, take a look, download the example, download the platform, and play with it. This is kind of the equivalent component of the Hadoop platform, but I have another slide that will let you that will go through in a little bit more detail. So ECL is the primary language of the platform. We talked about that. The way the platform works is your ECL gets compiled into C++ code, which is then it's a code generator for C++, which then gets compiled into DLLs, which for execution on the Roxy and the Thor platform. Your ECL programs can also inline C++ code. You can also use pipes to call out to other programming languages, which allows you to, so if you have libraries that you want to use, NLPs or machine language libraries and other programming language that you want to use on the platform, this allows you to do that as well. We also have support for Python, and Ruby. The latest version of the platform also allows you to access your data from Cassandra. So if you have a lot of data residing in Cassandra, then you could use the HPCC to not only refer to the data inside the HPCC platform, but also look at the data that might be in Cassandra. This is giving some for those of you familiar with Hadoop platform. What I'm trying to say here is give you the equivalence of the corresponding components on the Hadoop platform. Actually, let me move to the next slide. Where this is better shape. Okay, so this slide gives you the different components in the Hadoop and what their equivalents are in the Thor platform. So for those of you familiar with Hadoop, this lets you visualize. With Hadoop, you have the HDFS file system. We don't have a native file system within the HPCC. We use the operating system file system, and then we distribute the files across all the nodes in the cluster, and that's how that works. We don't have the equivalent of an HDFS. So your name node in Hadoop, the equivalent for that is a Thor master. Now, so there is so when it comes and the data node in Hadoop, we have are equivalent to the Thor slave. So very similar concept. So again, not a whole lot of difference there. When it comes to tracking the files, the jobs, and the job units, so you have the job tracker and task tracker. When it comes to Hadoop in the HPCC world, we have what's referred to as a DALI server. So the DALI used to have it used to use an internal a database for storing its work units, and we are now migrating to using something more off the shelf, maybe a Cassandra or Redis. Where we truly differentiate the platform is when it comes to the equivalent of, say, Hive. If you want to do searches using Hadoop, if you want to do B-tree searches using Hadoop, you have to use you end up using Hive or something equivalent to do searches. With the HPCC, you can use the Roxy cluster where you can build your B trees and B plus trees on Thor, and then you publish your indexes into the Roxy platform, and then run your searches on the Roxy platform. And the truly differentiating feature of the platform is the ECL programming language. So you can do everything from your ETL to your cleansing, to your modeling, to your learning, and using the same programming language, which is an extremely powerful proposition. There's one thing to use for the entire platform. So these are just a few examples of what we have in the ECL language. So for those familiar with the Hadoop platform, the map the equivalent of a map to do a mapping in the ECL, the primitive is project/transform. The equivalent of a shuffle phase one in the Hadoop platform would be a distribute in on the inside ECL. And the equivalent of a shuffle phase two would be a sort in ECL. And finally, the equivalent of a reduce would be a roll-up using the key. So again, for those familiar with Hadoop, the Hadoop ecosystem, this is you're going to be right at home with this platform. The only major difference being this is you can do all of it kept nicely bundled together in one platform, so you can focus on your problem and not the operations engineering part of it. That in a nutshell is what the HPCC systems is about. It's a comprehensive platform. I know this is a data science conference. So for the data scientists amongst you, we have a very comprehensive machine learning module inside ECL that you can use from within ECL. So please, I welcome you to come check it out. Go to hpccsystems.com and you'll see the machine learning modules right there. Again, this is enterprise ready. We've been using this for a long time in its current form. We have a large group of engineers who are working on this full time, who not only maintain it for use inside my company, but it's also we are trying to grow the community. Like I was telling you earlier, this platform developed outside the glare of Silicon Valley, so it hasn't. So this is an effort to outreach the wider community of data scientists more than just your classical big data processing. So yeah, we have a comprehensive academic program as well. We are partnering with a few academic institutions where we are offering HPCC certification and HPCC platform courses. So if anyone is interested in that, please go to hpccsystems.com. You'll find links to that. There's a comprehensive set of tutorials available at hpccsystems.com. So introductory courses. And for advanced courses, for those of you in the audience who have attended this conference, we are going to offer free training. So I have my email address at the end of this presentation, so just contact me, and we'll get that set up for you. Anyone who's interested. So these are the final links to everything that I talked about today. So my email address is right there at the bottom. Feel free to send me any info, any questions, any more details that you would want on the platform. I'll be happy to talk to you about it. Any questions? All right. Good. Thank you.